Okay, so we are now going to continue on to section 7. Radicals. We're going to do 4 objectives. Objective 1 is use the product rule for radicals. Objective 2 is use the quotient rule for radicals. Objective 3 is simplify radicals, and objective 4 is using Pythagorean theorem. Okay, so for using the product rule for radicals, consider the expression the square root of 36 times 4 and the square root of 36 times the square root of 4. So the square root of 36 times 4 is equal to the square root of 144, which is equal to 12. Whereas the square root of 36 times the square root of 4 is equal to 6 times 2, which is also 12. So the result is the same. This is an example of the product rule for radicals. So basically it tells you if you have the nth root of A times the nth root of B, then you can figure it out as well as doing the nth root of A times B. Notice that the product of the two nth roots in the nth power of the root of the product. So you have to have the same index in order to use this product rule. So let's do some examples. Okay, so for how we work these problems, we need to check that the indexes are the same. In this case, we have 2 square roots, so we have the same indexes, both being a 2. So we're just going to take the square root of 7 times 11, and we would get the square root of 77. We can prove this to ourselves by using the calculator. So if we clear this, we would take the square root of 7. Actually, let's do it this way. Let's do the square root of 7. Oh, what happened there? I don't know. Second square root of 7 times the second square root of 11. And you get that answer. Now, if we do the second square root of 77, you'll see that they are identical. Okay, so that's literally what I'm saying to you guys when I say use the calculator to help you guys on this test. Some of the stuff you can literally double check that you're doing the answers correctly. So here we would do 2mn times square root of 15. They're both square roots, so we'll do 2mn times 15, and that will get us the square root of 30mn. Now, they tell us here that all variables represent positive real numbers. If they didn't have that, here you would have to include m greater than or equal to 0 and n greater than or equal to 0, but you don't have to do that here because they've already told us that. However, if you remember this for the test, then kudos to you. All right. Next example is dealing with different indexes. So let's look at the first example. We're looking at a cubed root of 4 times a cubed root of 5, which is nice because the root indexes are the same. So we can go ahead and use the rule. 4 times 5 would give us the cubed root of 20. Again, if you really wanted to, you could go into the calculator and check that yourself. I'm not going to because I just did. Okay, here again, the indexes match. So we can use the rule 5t times 6r cubed, and we get the 4th root of 30. Really, we can do r cubed t. Okay. Yes, excellent. Okay, C. Indexes again are the same, so 20x times the 7th root of 3xy cubed. We get the 7th root of 20x times 3 xy cubed. So that gives us 7th root of 60 x squared y cubed. All right, and the last one, unfortunately, is not the same indexes, so we can't simplify. So and even if we wanted to write it in exponential form, we don't have the same bases, therefore can't be simplified. So the answer you would write on the line would just be what you're given. Okay. All right. Objective 2, use the quotient rule for radicals. The quotient rule for radicals is similar to the product rule in that we've been kind of using this. I've been using it along in the videos. If we're given the nth root of a fraction, we can actually split it to be 2 nth roots on top of each other, as long as b is not equal to 0. And then we can find the nth root for each one, if it's possible. Later on, we're going to see that if we have a radical in the denominator, we have to actually have to do something called rationalizing the denominator. So we will go over that process in a little bit. All right, so for A here, if you didn't want to, you could go straight to the answer if you preferred not to do the steps, but in case folks need to see the steps, we do the square root of 49 over the square root of 36. We know easily that the square root of 36 is 6, and that the square root, of 49 is 7. You could also give me plus or minus the square root of 7/6, because, or the square root plus or minus 7/6, because it is a square root, so we can have both plus or minus. Up to you if you want to remember that. I will take either answer, but it can be a negative there as well. For B, we have the square root of 5 over 144. Now, the square root of 5 does not exist, but the square root of 144 does. So that gives us technically plus or minus the square root of 5 over 12. That's one option. Or I would take square root of 5 over 12. Either one. My preference is this one, but of course, it can be either. Okay. C. Cubed root. Now we can have a negative underneath because it is a an odd index. Remember, if we have an even index, that would be not a real answer, but this is an odd. When you split it, you can either pull the negative all the way out front because you know that's going to be part of the answer, or you can just make sure that you put it with one or the other. You do not want to put it with both. So your answer here is 3 over 10, negative 3 over 10. Okay, green. D, the 4th root of t over 16, which is the 4th root of t over the 4th root of 16, which is the 4th root of t, doesn't really change, over 2. Again, you could have the plus or minus. I'm fine either way. If you do, just make sure that you know when it is and even, that you can give the plus or minus even index. If it is an odd, you want to stick with just the negative or the positive, depending upon what you were given. Okay, so the last one here is E. So we have a negative on the outside, and we would write it as the 5th root of m to the 15th over the 5th root of 243. Now, notice over here in D, the 4th root of t would have just been t to the 1/4. That wouldn't change. However, here, 15 over 5 does reduce, so we do want to pull it out. The 5th root of 243 is 3. So we have negative m to the 3rd power over 3. Okay. All right. Simplifying radicals. We use the product and quotient rules to simplify radicals. A radical is simplified if the following 4 conditions are met. The radicand has no factor raised to a power greater than or equal to the index, which means we can't pull it out. The radical has no fractions. No denominator contains a radical. And exponents in the radicand and the index of the radical have greatest common factor of 1. Again, that's just saying that you can't really reduce anything anymore. Okay, so let's take a look at this. For A, we have the square root of 50. Well, we know that the perfect square within 50 is 25, and 25 times 2 will give us 50. So then that is 5 squared times 2. And it's 2 to the 1st, just so that you guys need, if you guys need to see that. So because the index and the first exponent here, the 2 match, we're going to pull 1 5 out. It's kind of like you have to pay. You can't, for each group, you can only pull out 1. You can't pull out more than that. And then the 2 is left. And really, you could have a plus or minus here. Okay, B is the square root of 192. The perfect square within 192 is 64. If you have a hard time seeing what the squares are, you can always use your calculator and figure out the factors of the first number. So for 50, we would have found factors of 51 and 50, 2 and 25, 5 and 10. But we know we can stop at 25 because that's a perfect square. Same thing with 192. As soon as you get to 64, you know that's a perfect square. Again, we can have a plus or minus here, take it or leave it. My preference is to have it, but I'm not going to ding anyone who forgets it. Square root of 42. Now, the factors of 42 are 1 and 42, 2 and 21. I believe, yeah, 3 and 14. And then 6 and 7. Now, none of those are perfect squares. So we can't really do anything else. So that is it. So this is your answer here. You could technically have a plus or minus if you really wanted it. It's fine for this one if you left it off. So here we would say no perfect squares are in 42. All right, D is the cubed root of 108. Now here you do not need the plus or minus because it is a odd index. The perfect cube within 108 is 27. Again, you can use factors like you did when you were factoring. So once you find your perfect cube, you then pull it out and you leave the other guy behind. All right, for E, we will have a negative answer only because the negative is outside of the radical. The perfect fourth within 80 is 16. So you can see that 80 is a perfect fifth root actually. So then, oh, nope, I lied. It's not times 2, it's times 5. So it's not a perfect fifth root. That would be 32. So we're going to pull out a 2, fourth root of 5. All right. Good with that one. Getting pretty close to done on here. Now here they're just bringing in the idea of how to simplify variables with exponents under the radical. Well, again, what we want to look for is groupings. So here we would have 6 squared, but then remember with exponents on variables, what we can do is we just add them. So we could have x squared, that's one group, so 1x, x squared, that's another group, so another x, so x times x, and then x left. Well, 2 plus 2 plus 2 plus 1 will give us back to our 5. So that's how we get that. And then we're going to pull out 1, 6, 1x, and 1x. And then be left with just an x inside. So that reduces, or that simplifies really to 6x squared square root x. Okay. Excellent work. All right, here for B, we have the square root of 32, which is 4 squared for 16 times 2. And then we'll do m squared times m squared times m times n squared times n squared. And then we're going to pull out a 4. We have 2 groupings of m's, so we'll have m squared, 2 groupings of n, so we'll have n squared, and then we have left 2 and an m, so 2m inside. All right, and if you need to watch the video again to figure that out, go ahead, pause it, rewind it, whatever you need to do. I didn't do the steps as shortened as I did up top, but that's because the first one I did it, so you guys should be able to follow it the second time. All right, so cubed root now is negative 125. Actually, let's just go ahead and rewrite that as the root. It's going to be so negative 5 cubed. And then we already have k cubed. So this time we want to have it in groupings of 3. So we're going to have p cubed and p cubed, that gives us 6, and one more p will give us a 7. So we're going to pull out 1 negative 5, 1k, 2 p's, and have 1 p left over. So we will have a negative 5k p squared cubed root of p left inside. Okay. And the negative 4th root of 162 is made up of 81, which is, I'll just go ahead and write it like this for you guys to see it for the moment. And then I'll break it up. So 4th root, that's going to be 3 to the 4th times 2. And then we want to have groupings of 4, so x to the 4th times x cubed. 4 and 3 give you back to the 7, and then times y to the 4th times y to the 4th. So that'll give you a negative 3, 1x, so a 3, 1x, and then 2 y's, so y squared, 4th root, 2 left inside, and an x cubed left inside. Okay, and remember here that the negative is only included because it was on the outside of what was going on. Otherwise, we would not have a negative for an even index. All right, here we're just asked to simplify. So 6th root of 7 squared, we can rewrite that as 7 to the 2/6, which is the same as 7 to the 1/3, which is now the cubed root of 7. That's one way to do it. The other way to do it is to look at this and realize, well, 6 to the 7 squared, 2 goes into 6 3 times. So I can go straight to the cubed root of 7. You can see that they both are the same, no matter which option you choose there. So for B, we'll have 6y to the 4th, and we'll do both options again. Y to the 4/6 is the same as y to the 2/3. So the cubed root of y squared. Again, you could get there by looking and seeing that both the index and the exponent can be reduced by dividing by 2. So you would still get to the cubed root of y squared. All right, and then the last one is C. 4th root of x to the 10th, both can be divided by 2, so that would be the square root of x to the 5th. However, now we need to look at our grouping. So x squared times x, that gives us x to the 5th. We're going to pull out 2 x's, so x squared square root of x is our answer there. So you need to remember that that is taking care of that last checkbox that says that no inside exponent is going to be more than the index, which in this case it would have been. So that is why we had to finalize it like that. Okay. All right. So last objective for this lesson is Pythagorean theorem. You will only have to deal with right triangles. Your class does not do any other triangle missing lengths. So you would need to do trig for that, and we are not there. So the right triangle is denoted by this little square kind of in the triangle. It stands for a right angle, so equal to 90 degrees. And across from it is always the hypotenuse. And then we have leg A, which tends to be shorter, and leg B, but they are kind of interchangeable because of the algebra involved. So for A here, we need to find C. We are given an A of 5 units, a B of 8 units. We know that a squared plus b squared equals c squared. So we would have 5 squared plus 8 squared equals c squared, which is 25 plus 64, which is equal to 89. Normally I would say, aren't we done here? But we need to find c, not c squared. So we take the square root of both sides. So c is equal to the square root of 89 units. And normally we would say plus or minus, but we are dealing with lengths, so you can only have pluses. We also were not told that we need a decimal equivalent, so we are fine leaving it as the square root of 89. Okay, for here, we are given an A of 6, a C of 12, and we need to find B. So we can rearrange this equation to be set up to be solving for B. So we would just subtract a squared on both sides. So we would get b squared equals c squared minus a squared. And actually, we could take the square root of both sides. So b is equal to the square root of 12 squared minus 6 squared. which is the square root of 144 minus 36, which gives us b equal to the square root of 108. And if we simplify that a little bit, we know that there is a 36 in 108, so that's 6 squared times 3. So then b is equal to 6 square root of 3 units. Boop, boop. There you go. And that is the end of lesson 7.3. I will see you back here for 7.4 shortly.